Hi there, this is Mr. Alexander. As I'm sure your teachers made you aware, today you're going to watch 4 videos and take 4 knowledge checks. This video is the first of the 4, and it's covering exponential growth and decay. I'm sure your teacher's given you a piece of paper with some blank squares, rectangles in there, and this is the first of those 4 rectangles. And I want you to quickly copy down this information. The exponential growth and decay function is y equals a times b to the x power, where x is a period of time like days or hours or years, and y is the value after that amount of time. A is the starting amount, and b is your growth and decay factor. Now I made a little note above here. It says when b is greater than 1, that's growth. When b is between 0 and 1, that's decay. So we're going to use these values in this equation to solve a few word problems, which I want to talk about right now. So, first one. In the year 2000, the population of Mexico was about 100 million people. Write an exponential function to model this situation if A, the country was growing at 1.53% per year, and B, the country was shrinking by 2.04% per year. So it's we're going to write a function. It's going to be y equals something times something to the x power. The first something is the initial value. What Mexico started at the year 2000, that's 100 million people. So 100, 00, 00, 000. 100 million. And what goes right here, it says it's growing, so it's going to be a growth factor. Now to figure out what that growth factor is, the way I like to think about it is when you're growing, it's going to be 1 plus whatever your percentage is, 1.53 divided by 100. So that's just calculator work, and I'll zoom in so you can see what I'm typing into my calculator. 1 plus 1.53, that was the percentage, divided by 100. So my growth factor is 1.0153. That's what I'm going to type into my equation here. 1.0153. So my exponential growth equation is right here. Now, if the country's shrinking by 2.04% per year, that's going to be an exponential decay equation. And it's going to be y equals the same. It still starts at 100 million. But now my decay factor is going to be something different. And the way I like to think about that is 1 minus the percentage, 2.04, divided by 100. So that's calculator work as well. Decay is minus, growth is plus. So 1 minus 2.04 divided by 100. That's my decay factor, 0.9796. 0.9796. And that is the equation that models that country's declining population. But sometimes we write equations, sometimes we use equations to solve the problem. So let's talk about a different one here. A lion is introduced into a colony of 20,000 mice during an ecosystem experiment in an attempt to thin the population of the mice. The function below can be used to model the number of mice after d days. What amount of time is needed for the population of the colony to drop to 14,000 mice? Well, first off, this should probably be a D, not an H. I apologize for that. And we want to figure out how long it takes using this equation for the population to drop to 14,000. So that's a y value. So I'm going to plug in for y. That's 14,000 equals 20,000 times 0.752 d divided by 4. Now I'm trying to solve for d. I want to know how many days it takes. The first step here is to divide both sides by 20,000. And that's going to give me 0.7 equals, now those 20,000s cancel out, 0.752 to the d over 4 power. At this point, we're left with an exponential that we need to solve. We got to get that d out of the exponent somehow. And I'm going to use my logarithm rules. Now remember the rule here, y equals b to the x. We can rewrite that as a logarithm if we write x equals log base b of y. So I'm just going to rewrite this exponential equation as a logarithmic one. So I'm going to start with my x, which is the exponent, d divided by 4, equals log base 0.752 all raised, or to the power, not to the power, but log of 0.7. So you might be asking yourself, how does that help me? But remember the other rule that I'm going to write over here. Log base b of a equals log of a divided by log of b. And that's just a little way to help you remember what to type into the calculator. So d over 4 equals log of a, log of 0.7, divided by log of 0.752. But the d is not by itself yet. It's still divided by 4, so I need to multiply both sides by 4 to get the d by itself. So d equals 4 times log 0.7 divided by log 0.752. And at this point, it's calculator work. So I'm going to type that in. I'll show you how to do it. Zoom in. 4 times log of 0.7 divided by log of 0.752, close parentheses. And it looks like it's just about 5 days. We'll just round that to the nearest day. We'll call it an even 5 days. And what's really important on word problems is that you always label your answer with units. In this case, the answer is 5 days. That's how long it'll take for that ecosystem of mice to drop to 14,000 from 20,000. So that's a really hungry lion, it turns out. Okay, thank you for watching. Good luck on the knowledge check, and I'll see you on the next video.